Hello everybody, this is Mrs. Lindsay Pereira. Today we're going to do our first day of 3233, talking about parallel lines and transversals. Alright, so we introed parallel lines, different types of angles, transversals in the first unit. But now we're going to go into more specifics about what happens with our parallel lines here. So let's talk about, remember our symbols from before here, where these arrows or double arrows mean parallel, or again, you can write it out as line BC is parallel to DE. But in between the two parallel lines is what we call the interior, like kind of above and below, can be exterior. But remember, this could be also rotated, you know, so if I'm looking at something like, let me try to rotate this. I thought I was able to. Here we go. You know, that now changes, I can erase these here, the interior. So depending upon where this actual figure is, however the parallel lines are, in between them will be the interior. Okay, so if I go to this actual website here, kind of allows me to play with this just a little bit. Here they're describing parallel lines. This one you can try by yourself. Again, you guys have that. But I kind of want to talk about the pairs of the angles here. What's going on with this? So again, you have a transversal. You can see that we have a lot of, again, supplementary vertical angles, which we've talked about before. And then we again have all of our different types of angles that we talked about. Corresponding angles, so A and E, right? B and F, C and G, D and H, okay? Alternate interior angles, C and F, D and E. We got a lot of pairs of those. Okay, so what happens with these as we move this along? And hopefully you'll notice, let's just take a look at one pair of them. Let's look at consecutive interior. So these are consecutive interiors, same side of the transversal. These are also. So again, as I move these lines, what's the relationship you're seeing there? This is even a very more specific one. Hopefully you're noticing, okay, these are not only supplementary here, but our consecutive interior ones are also supplementary. Okay, so if we jump back to our notes here, two lines are cut by a transversal such that, and again, if we need to refer back to that, what would be congruent? And again, I kind of have taken this off of the thing there. So what would be congruent? Corresponding angles, alternate exterior, and alternate interior. So corresponding angles, alternate interior angles, and alternate exterior angles. They are congruent. Again, so if two lines are cut by a transversal such that these occur, then we know that the lines are parallel. What I first started talking about was supplementary, and these are again consecutive. You could also say same side interior angles, and also, I didn't mention this one, but this is also true, consecutive exterior angles. These are supplementary. Okay, so if we can show these relationships, we can prove lines are parallel. Okay, and then of course we have shortcuts we always use when we're talking about our proofs. We can cut out the part of the transversal. These are written in if-then format here. For example, I'll just read one. If alternate exterior angles are congruent, then lines are parallel. And again, we can write that in our shortcut format as well. In terms of, I was reading this one, alternate exterior angles. Don't forget to say what they are. Some people forget that and they want to just say, implies parallel lines. Well, what about alternate exterior angles? They must be congruent. So alternate exterior angles congruent implies parallel lines. That's the shortcut we can use with our proofs. Okay. So what do you think? Is the converse also true? Could I say if lines are parallel, then alternate exterior angles are congruent? Would that work for all of these? If lines are parallel, could I then say consecutive exterior angles are supplementary? And hopefully you're thinking, yes, and that is true. So if two parallel lines are cut by a transversal, so again, we're talking about congruent here, alternate interior angles, alternate exterior angles, and corresponding angles are congruent. So again, the reverse works as well. And then for the supplementary portion, these are always your same side. Okay, they already say same side in here, so I'm not going to list that twice. So again, you can list this as consecutive as well. But interior angles and exterior angles. So again, it's implied here though that these are consecutive. It's just written below here. So again, that works in both cases, both directions, I guess I should really say. Okay. So it is fairly straightforward when you're only looking at a diagram that has, for example, the parallel lines and a transversal. Okay. So if I'm looking at this diagram here, what value of x makes m parallel to n? Well, we have here alternate. Again, they're interior. They're in between the lines we're trying to prove. So this would be the interior. And they're alternating over the transversal. So alternate interior angles should be congruent. So if we want to make it so these lines are parallel, we need to set them equal to each other to find that value of x. So subtract over 2x, add over 5. That would give us the value of x that makes the lines parallel. Okay. So let's try another example. When lines R and S are cut by a transversal, angle 1 and angle 2 are same side interior. So let's go ahead and read that because that's something we need to draw. When lines R and S are cut by a transversal, I'm going to draw it this way just to show a different direction than what we had in the previous problem. So there's line R and line S. And I'm going to cut it by a transversal. Angles 1 and 2 are same side. So I'm picking same side and interior. Could have put it on the other side. Doesn't matter as long as they're same side interior. If angle 1 is 3 times angle 2, so we'll call angle 2 x. We'll call angle 1 3x. Can line R be parallel to line S? Can line R be parallel to line S? I would actually like you to try to do this one on your own and then push play when you are ready to resume and we'll go through it. Okay, so let's think about this a little bit. If we have this relationship, they should be supplementary. So I should be able to add up those same side angles, set them equal to 180. So we get 4x equals 180, so therefore x would be, I believe, 45. Okay. So now let's answer this question here. If measure of angle 1 is 3 times the measure of angle 2, can R be parallel to S? And the answer is yes, if the measure of angle 2, because that's x, is 45 degrees. And I actually should maybe explain a little bit more. Then consecutive or same side interior angles would be supplementary. They didn't really ask me to explain there, but it's a good idea to kind of get used to that because there will be times where we need to explain some things there. Okay. Moving on to our next example. Now this one with highlighting the lines I think is very, very helpful because it doesn't just show the 2 lines in the transversal we're referring to. So I'm going to highlight AB and notice I draw it off of the diagram. I'm extending it through A, I'm extending it through B, as well as DC. I'm going to extend it off the diagram. Now if you notice, I actually have several transversals I could use. This is a transversal. This is a transversal. This is a transversal, and I still even have another one. DB is a transversal. Okay, so if we take a look at these, we got to be a little bit careful. And again, notice I extended every single one of those through the diagram. this angle refers to the parallel line AB, well, the line to see if it's parallel, and the transversal. The angles we're always referring to have to go from the parallel line to the transversal. So 155, notice that transversal cuts through it. I don't know how it cuts through it, but 159 would not apply to these angles here, or sorry, these lines. Okay, so we need to focus and see, okay, which transversal will help us prove yes or no, AB is parallel to DC. Okay, if we do take a look at this one transversal, I just happened to erase it. There is an angle we can look at. It's not the 155 though. It is the alternate interior angles. So yes, because alternate interior angles are congruent. And again, make sure you say what about those alternate interior angles make that true. Okay. Now we're switching gears. Part B says, is BC parallel to AD? Now I know this is easy for me to do. I can simply just erase this. However, what I would recommend is redrawing it again in your notes. Okay, sometimes it can be very challenging again when there's a lot of lines. Just simply take an extra 15 seconds, redraw it, highlight the lines that we're trying to look for to see if they're parallel. If you can see it without doing it, it's fine, but it's, again, what do you do when you can't see it? What are some options you can do? Okay, so again, we have a lot of transversals. We can do DC, DB, AC, AB. All four of these lines are transversals. Okay, so let's just start with highlighting one. Let's see what we come up with here. My first thought is, let's just start with the top one. Does that prove or disprove that these lines are parallel? And hopefully you see already, it's going to dictate the answer to this question. I'm looking at this angle here, 155, which is not congruent to angle 115. Again, please notice I'm drawing it from the transversal and it has to hit the parallel line. Transversal to the parallel line. Okay, so if I do this one, these are same side. So they're talking one interior, one exterior. These are corresponding angles and they are not congruent. So this would be no, because corresponding angles are not congruent. Okay. A lot of people want to look at this. Let me use a different color here. This line, which is also a transversal, and say this 65 and 65 are congruent in their alternate interior, but they are not alternate interior because remember, it has to go from the yellow line, which is the parallel line we're trying to prove, which is not parallel, we just showed, all the way to the transversal. So from the yellow to the blue, 65 is only part of that angle. We don't actually know what this angle measure is on either side here. So again, make sure you're always drawing it from the parallel line to the transversal. Okay. And last but not least, we got a proof here. Okay, I'm going to write it as a flow chart. So let's go through this and we'll talk about it being congruent and mark our congruent symbols here. We've got 5 is congruent to 6. Then we also have 6. So notice how I already have a marking there is congruent to 4. So hopefully you're taking a look at this and see, oh, transitive property. Again, this is me just kind of writing some notes on the side. I can get 5 congruent to 4. Does that help us prove AD is parallel to BC? And again, I kind of like to highlight that. Let me see. AD to BC, yes, if I use this transversal, now I've got alternate interior angles, so yes, that helps us. Now we just need to write that up. So angle 5 is congruent to angle 6. That is given. Angle 6 is congruent to angle 4. Also given. So again, our link, both of these are our links, so we put arrows from both of them because that helps us prove that angle 5 is congruent to angle 4. And again, we only need to write transitive here because the arrows represent us writing the links. And then we can go right to our proof statement showing that AD is parallel to BC. And again, what kind of angles are these? Those are alternating interior angles, are congruent, implies parallel lines. So again, alternate interior angles are congruent, implies parallel lines. Okay. All right, and this concludes our first day on parallel lines, and we will continue it the following day.